Good evening, everyone. Okay, so this evening we are extremely pleased to have here with us Professor Patrick Wong. Professor Patrick Wong is a cognitive neuroscientist, linguist, and speech-language therapist. He is professor of linguistics and professor of otolaryngology, and serves as the founding director of the Brain and Mind Institute at the Chinese University of Hong Kong. His research examines cultural and biological factors that lead to variation in language and cognition across individuals. This body of work has appeared in different interdisciplinary scholarly venues, as well as media outlets such as popular media outlets, such as the New York Times and Scientific American. Professor Wong is also the recipient of several prestigious awards and other recognitions. So let us give a round of applause to Professor Wong.
Thank you.
And before before we start, however, I need to remind everyone, I need to make a technical reminder, sorry. Please do not take photos and do not record videos or audio, No video or audio recording. Another photo. Thank you very much.
Okay, thank you. So I hope you can hear me okay. Okay, good. So I'll be talking about language and music and the brain and babies and child development. And usually I give a talk like this to parents, young parents who have little kids. And so if you have children as well and are interested in this topic, and if you have questions, please let me know. And feel free to interrupt as well, because I know that this is an interdisciplinary kind of talk. And you may know a lot about something, but not a whole lot about something else. So please feel free to interrupt. Okay, so as I said, I'm going to be talking about language and music and the brain and development. My interest lies in how we hear. And so my interest in language has to do with spoken language. And also I'm interested in music. And today what I'm going to do is I'm going to highlight research conducted by members of my laboratory and also many other labs in the world. Topics that I think that are interesting, at least to me, and I hope they'll be interesting to you as well. So we know that our nervous system supports both language and music, spoken language, in this case for today. We need our auditory system to perceive both spoken language, speech, as well as music. Now, one very interesting thing, at least to me, is that as early as 19 weeks in gestation in mother's womb, we have evidence that babies can actually hear, the fetus can actually hear. There are many actually research studies about that. The earliest that I can find is actually 19 weeks of gestation. As you know, 30 weeks of gestation is full term. If you're born before that, that's preterm. But even 19 weeks, about half of your lifetime in your mother's womb, you can actually hear. And early hearing may provide foundation for what we call experience-dependent neuroplasticity, and we'll talk about that today. So, oops, goes very fast. So as I said, we'll focus on research findings by different laboratories in the world that look into the relationship between music and spoken language, child development, and the brain today. I'll focus on studies that looked at plasticity and stimulation, different types of language and music stimulation. And then if we have time, we'll talk about strategies for enhancing language development in children. That's a topic that parents always ask. And so if I have the time, I'll go through that today. Okay, so first of all, let's talk about, I'm going to be talking about the brain, and I'll be talking about music and language. Now, how do we know that a baby can hear? How do we know that an adult can hear? Well, we can tell that an adult can hear by asking if the adult can hear, right? Now, when we are studying babies, we need some more objective way to measure whether or not a child can hear. Now, our focus here is on the nervous system. So let me give you one example of the type of studies that we do that tells us whether or not the child can actually hear. So we call this method neuroencoding of speech. So it's an EEG test, meaning we put electrodes outside of the skull. We don't have to directly measure activities of the neurons. We can actually make measurements outside of the skull. what we can do is that we can play a sound to, in this case, an adult, but I'm going to be showing you some infant data. So we can play a sound to an adult here. And then this electrode here, we call it an active electrode. We can measure the brain wave that's generated by stimulating, by auditorily stimulating this person. Okay? In other words, we can present the sound wave to the person, and then what we get out from this person is a brain wave. Okay? So I'm going to give you two examples here. So first, I'm going to play a low pitch to this person. Okay? And then I'm going to play back to you the brain wave that we measure from her. Okay? So like this. Okay, can you hear that the pitch information is preserved? So low pitch, and then I'm going to do high pitch. High pitch. Okay, we call this neuroencoding because we're looking at how much the brain is taking in and coding that sound. Okay, so this technique that we do is really good at detecting pitch information. What kind of pitch is the child or the adult in this case hearing? Is that signal being preserved faithfully or represented faithfully in the nervous system of this listener? Okay, so there's a special name for it called the frequency following response. But for the purpose here, we're just going to call it neuroencoding of speech because the nervous system, the neurons are encoding the sound wave. Okay, and then we can measure the brain wave. We can compare the brain wave with the sound wave to see how accurately or how faithfully the listener is representing that particular speech signal. Now, these are three examples of babies listening to three different stimuli. I'm going to play you what we play to the baby, and then I'm going to play you what we recorded from the brain of that baby. Okay, so pitch is preserved. Okay, more or less pitch is preserved. And so this is just what we call pitch tracking data. So the black line is the pitch pattern of the stimulus that we play to the baby. And the yellow line is what the baby's brain is actually following. So in these three cases, you can see that the babies are actually doing pretty well, but they are not perfect. Now, we are interested in how this particular type of signal from the brain, from the nervous system, develops. Okay? So there's a maturation pattern of this signal. So here I'm just going to show you two examples, two time point examples. One is 1 month, and another one is 9 months, across three different Chinese stimuli, 2 Cantonese and 1 Mandarin. Okay? So you can see on the left here, 1 month, you don't need to know how to read these graphs to know that this is better looking than this one. Okay, I'm not going to go into the detail, except that we know that child within the first year of life develops very rapidly in terms of how to represent the incoming speech signal. Okay, so this is a very robust and very faithful kind of representation. This is not very faithful. This is pretty noisy. Okay, and there's actually individual variability. Some babies can do it better than others. We know the neurological sources of this signal. So we know that it's related to what we call dendritic processes. So when you look at the neurons, there are different parts. One part of it is called dendrites. Dendrites receive information. We know that from 1 month to 6 months, there's a very rapid development. And the signal is actually related to this dendritic processes, as well as what we call myelination. So when you look at a neuron, they're white matters. And white matters, again, mature very rapidly within the first year of life. And that signal is actually associated with myelination process as well. Okay? Now, we look at, in our lab, we study a lot of babies. We also study toddlers. We also study adults. And so let me give you an idea of how infants compare to adults. So here you can see that this infant, there are actually 2 different infants here. They do pretty well, okay? But it's not, this yellow line is not on top of the black line. Ideally, we want it to be on top of each other. Now, if you look at the adults, adults are a lot more faithful than infants. right? So there's a maturation process going from infancy to adulthood. And we're actually doing studies kind of document this process. And we are doing a 5-year longitudinal study following 300 babies from birth to 5 years. And we actually have some data looking at how they follow these pitch changes. And as I said earlier, this signal mature very rapidly in the first year of life. In fact, in the first 2 years of life, okay? And we published the results last year. Okay, now, we know that neurorepresentation or neuroencoding of speech mature in the first few years of life. Now, the next question that we're interested in answering is whether or not there's a relationship between how the brain represents the signal, how the neurons develop, and their future language development, okay? And I'll explain to you why we're interested in that in a minute, but let me tell you the results first. And the answer is that yes, we can actually make a measurement from babies and then use that information to make prediction about how well they develop language 2 years down the road, okay? So how did we do it? So in this, now we have like 400 babies, but this is a study that we published last year. We had 118 babies. All of them went through this EEG test that I just told you about, okay? This neuroencoding test, okay? And we follow them. I told you that we're doing a longitudinal study, so we're following the development of these babies. Now, with these 118 babies, we have their language. We also have their baby EEG data. And so we use machine learning methods to try to connect the two to build a predictive model, to try to predict, to try to use neuro data from infancy to predict language development in toddlerhood and preschool years, okay? So we use machine learning, and these are the results. So we can actually, so let me see, yeah, okay, here. So we can use these signals to make prediction about their vocabulary comprehension using what's called the CDI, or vocabulary production. Now, we can make prediction using what we call pediatric factors, like birth weight, gestational age, because we know that if you're born preterm, your language is not going to be developed as well as children who are full term. If you are born very light, not very heavy, that's actually also an indicator of how well your language would develop as well. We can use those pediatric factors to make prediction. Now, the important thing is that once we add this green stuff, the green stuff is the neural measures, our prediction is a lot more accurate, okay? So we're talking about upper 80s in terms of our predictive accuracy and precision, okay? Now, let me give you 2 examples of 2 babies. So this is a poor speech encoder. This is a better speech encoder. So this, you can see that this is brighter and smoother. This is kind of broken, okay? So this is a better encoder than this baby. So these 2 babies, we follow them for 2 years. And this baby ended up being at the 90th percentile in the CDI scores, and this person is, ended up being at the 10th percentile. Now, why is there a relationship between speech encoding, neurospeech encoding, and future language development? Well, at least for early language learning, speech is the foundation of learning words, okay? And we're measuring words here, okay? And so Chinese, for Cantonese, these are 2 Cantonese examples. So Cantonese have something called lexical tones, okay? When we change the pitch of the syllable, we change meaning. So not everyone, just that you speak Chinese doesn't mean that you know this, actually. But this is what we can do as speakers of Chinese. So in Cantonese, you can say si, 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 okay? So then there are 6 different words. In Mandarin, you can say ma, 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 okay? So there are 4 different words. So for example, in Cantonese, yu, 一條魚嘅魚, so with a tone 2, 落雨個雨 tone 5. When you change the pitch, you change meaning. So remember at the beginning when I told you about our EEG method, that EEG method is really good at preserving pitch information, right? So it tells us whether or not the brain is hearing that pitch information. And because Cantonese has this characteristics, at least for Cantonese babies, we're able to use this method to make prediction about their at least their vocabulary development. Actually, we have now data about development further away from word learning. Okay, so that's the reason why these 2 things connect, at least. Okay, we can use the same method to study children with and without autism spectrum disorders. Okay, so as you know, some children with autism, some of them at least, have problems understanding pitch information and prosody, what we call prosody. So they can infer meaning from the high pitch and the low pitch at the sentence level. Okay, so that's why we're interested in using this method to study children with autism as well. And so we published this paper last year. This is some examples of our results. So this is a child with autism spectrum disorder. This is a child who's typically developing. When you compare the two, you can see that the child who's typically developing is following that pitch pattern pretty well, their brain, okay, their nervous system. If you look at the child with autism is all over the place, okay? So this is a method that we can use to differentiate these two groups. We have some data on preterm infants as well. So preterm infants, a large percentage of them will end up having some sort of language difficulty when they're school age, okay? Especially the very preterm ones. So we can use this method to help us understand, to predict whether or not a particular child would likely end up having some kind of language difficulty. Okay, we just submitted that data for review. Just on the side, if you're interested, so we think that this is a method that's transdiagnostic for different types of communication difficulties. Okay, so music, going back to music for a bit. So as you can see from the data that I showed you, this method is about how the auditory system, the neuroauditory system processes pitch information, right? So if that's the case, it might be foundational to music as well. Some of you may know that, so if you look at, I think it's widely reported in the media that at least for adults learning a second language, those who have musical experience tend to be better foreign language learners. And so we conducted a study a while ago trying to understand why that relationship exists. So we used this method that I just told you about, this neuro method. We studied musicians who don't know Mandarin, and we presented to them some Mandarin stimuli to see if there's a difference between how well musicians encode these sounds compared to non-musicians. Okay? And what we found is that if you're a musician, even though you never learned Mandarin Chinese, you were able to encode Mandarin tones better than if you're a non-musician. Okay? These are group results, these are representative subjects. So perhaps one reason why musicians are better foreign language learners is because their auditory system is more sensitive to speech information, to be able to encode pitch, at least in this case, pitch information in their nervous system. And that helps us differentiate words better, and that would in turn may hierarchically help them to learn phrases and sentences and whatnot. Okay, that at least is a hypothesis. So there seems to be, from this study at least, neurally, there's a relationship between music and spoken language. Okay, so there's this relationship that we can trace back to the auditory system. Now, the next question that we're interested in, so if there's this relationship, the next question that we're interested in is whether or not a particular type of speech experience, spoken language experience, will shape how we perceive music as well. Okay? So more specifically, we're comparing tone language speakers versus non-tone language speakers. So Chinese is a tone language I've explained to you earlier. So Mandarin, Cantonese, we use pitch to signal word meaning. If you look at Indo-European languages like French and English, they don't use pitch to signal word meaning, right? Okay, so those are what we call non-tone languages. Now, if there's a relationship between musical pitch and linguistic pitch, if being exposed to a lot of musical pitch would help you process linguistic pitch, then the question here is whether or not being exposed to a lot of linguistic pitch will facilitate the processing of musical pitch. Okay? Is that relationship, the question clear? So if you speak Chinese because you're constantly hearing this pitch information, are you going to be better with music perception? That's the question that we're interested in. So we compare Cantonese speakers with French and English speakers across several music-related tasks. Okay, so these are examples. We tested them on rhythm perception and pitch perception when embedded in music. So a rhythm perception task will be like this. So in this case, they have to tell us that this pair of stimuli, musical stimuli, were different, okay? And they are different in rhythm, okay? So I'm going to present to you a pair of stimuli that vary in pitch. And the answer is no, they're different, okay? Because sometimes some of the trials are the same. Okay, so can you hear that they're different? Okay, so sometimes they're the same, sometimes they're different. So we put this experiment online, and so we recruited many, like hundreds of subjects conducting this task. Okay, and so then we compared the French and the English speakers with the Cantonese speakers, okay, to see if one group is better than others. The hypothesis is if linguistic pitch experience enhances musical pitch experience, then we should see the Cantonese speakers outperforming the French and English speakers, right? But only on the pitch-related task, not the rhythm task. Okay, so the rhythm task is a control condition. Okay, and so again, we collected a lot of data, and then we also collected their musical experience, musical training, their age, their educational background, because those are all related to how you perform on these tasks. After we control for those factors, we still found the Cantonese speaker outperforming the French and English speaker. So we did this study in Hong Kong and Canada. And so in the out-of-key condition and overall, but importantly, not in the offbeat, not in the rhythm perception, according to hypothesis, because it's linguistic pitch that the Hong Kong Cantonese speakers are exposed to a lot, okay? Not any kind of rhythm cues that are more than English and French speakers, okay? So it seems like this relationship between musical pitch and linguistic pitch, they're kind of mutually enforcing, and perhaps because it can be traced back to how the brain encodes pitch, speech pitch information. Okay? Any questions so far that I can quickly answer? Okay. So let me tell you about this next study. So if there's this relationship between music and language in terms of pitch, one question that we're interested in exploring is whether or not, if you are exposed to music for a long time, your own music that like your native instrument, would that then become language-like in your brain? Okay? Does that make sense? So if you're a violinist, more specifically, if you're a violinist and you play violin for a long time, would that processing in your brain be then closer to language processing in the brain? Okay, because it becomes like a native thing to you now. Okay, so this is beyond pitch. Okay, so we conducted this experiment. We asked a group of flautists, so they play flute, that's their native instrument. Okay, and then we asked a group of violinists, violin is their native instrument, to process flute music and violin music. Okay, so when a flautist listens to violin, that's like they're listening to their second language. When a violinist listens to flute, that's like their second language. When a violinist listens to violin music, that's like their native language. When a flautist listens to flute music, that's like their native language. So we have what we call a complete factorial design. Okay? And this is what we found. So by the way, I collaborate with Lisa Margulis, who's now at Princeton. We started out together as assistant professors, and so she is a musicologist. She's very picky about the kind of music stimuli that we use, and so here she and I had to So, as an experimentalist, it's important that we have experimental control. As a musician, it's very important for her that the music actually represents music. And so we came up with this paradigm in which we play a long excerpt of music to our subjects so that it can evoke whatever musical representations that might be going on in their brain, rather than just snippets. Okay, so we use a Bach patata for both violin and flute, so that we can control as much as possible the different features of the music. Okay, so this is the results. Now, here we found an interaction effect. So what happens is, when a violinist listens to violin, there's increased activation compared to when the violinist listens to flute music. The reverse is true for the flautist. When the flautist listens to flute music, there's more activation than when the flautist listens to violin music. Across several different brain regions, including the auditory cortex and the frontal lobe, in Broca's area 44 and 46. Importantly, it's all in the left hemisphere. Okay, so the left hemisphere, for those of you who might not be familiar, is most likely involved in processing language. Okay, and Broca's area is sort of a grammar area. So if we ask our subjects to do a grammatical judgment task of language, we see this area activated, okay, here. And then the auditory cortex, of course, the temporal lobe, the left temporal lobe, is very important for language comprehension, speech perception, evoking phonological features, phonological processes, okay? And so we're seeing this network, this interaction effect in the left side of the brain overlapping what's commonly known as the language network. So it seems like having your native instruments, listening to your native music, will evoke a very similar kind of brain network as well. Okay, so that's adults, and so I told you about some developmental studies. I'm going to switch topic a little bit to talk about learning before birth. At the beginning of my talk, I told you that even in the womb, babies can hear already. The fetus can hear already, starting from around 19 months of age. That has to do with how the auditory system is developed. So the cochlea is actually shaping, and then you'll see that they're beginning to be sensitive to the auditory signal. So from about 19 weeks. Now, the fetus is surrounded by water. Okay, it's not like how you and I hear when there's air around it. When there's water, the signal is what we call low pass filtered. That means that only the lower frequencies can get through. I mean, imagine you're like swimming underwater. You can't just hear like how we are hearing now, right? So the sounds are kind of muffled when you're underwater. So what the fetus is experiencing is this kind of muffled sound that's lower in frequency. What do I mean by lower in frequency? I'm specifically talking about the voice pitch. Like when you hear my voice now, I'm at about 150 hertz. That's a lower pitch. When you listen to a female's or a child, it might be at the 200 to 300 hertz kind of range. That is still a lower pitch level compared to a fricative like s, sh. Okay, those are about like 4,000 hertz. 4,000 hertz cannot get through the water surrounding the fetus. The voice pitch can get to the fetus. Okay, so a lot of times what the fetus is experiencing is this kind of voice pitch. So we have evidence suggesting that newborns is more sensitive to the mother's voice because the fetus keeps listening to the mother's voice, okay, for like at least 20 weeks, okay, if it's a full-term baby, okay? So it's low pass filter. Now, it seems like some learning may occur before birth as well, because of this maturing auditory system that has this low pass filter characteristic. So Partinen and colleagues did this very interesting study. I mean, it was published a while ago, but it's very interesting nevertheless. So they trained 17 fetuses in the womb okay, they asked the babies, the fetuses, to listen to 4 minutes of sequences like this, like ta, 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 to, ta, or ta, ta, ta. So sometimes they would change the vowel, sometimes they would change pitch, okay? And then there's another group of 16 families with no exposure. They're just going about business as usual, okay? They would do this for 5 to 7 times a week from gestational age of 29 until birth. So by 29 weeks, the auditory system is a lot more mature in the womb, okay? So they would listen to this 5 to 7 times for about 8 weeks, okay, depending on when you're born. At birth, they made EEG recordings to see if these now children, okay, neonates, will be able to differentiate what they've been trained on, the ta, 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 and the ta, to, ta, okay? Their pitch changes and vowel changes, and this is what they found. So this is an EEG measure that they did. They have a trained group and control group, and what they found was that if you're trained on the pitch condition, you were more sensitive. Your brain responded more to a pitch change in the vowel. You didn't see that in the control group, okay? Compared to the control group, the trained group is a lot more sensitive. Their brain is a lot more sensitive, okay? Now, you didn't see that difference with vowels, okay? Because vowels is of higher frequency, it may not have gone through, okay, all that water, okay? But pitch, we know it definitely went through that water, and the fetus was able to hear that, okay? So after like that 8 weeks of training, okay, when you measure these newborns, you can find differences in how their brain, because they can't tell you, they're babies, okay? But we can directly measure their brain, and it seems like the brain signal is different between the trained group and the control group. Okay, and we can trace back the difference to the frontal areas of the brain. Okay, so the frontal areas might be related to attention, but it may also be related to language areas as well. But with EEG, we can't really tell. Now, this is evidence suggesting that prenatal exposure leaves a signature in the young child's brain. This is not evidence saying that we should all begin to do prenatal training, okay? As far as I know, nobody has done what we call longitudinal study, following these trained babies for years to see if their language is better than fetuses who were not trained, okay? This is just telling us that these fetuses, these newborns, are now sensitive to these sounds that they were trained on while they're in the womb. But we don't know how long-lasting that effect might be. There are actually some follow-up studies. 3 months later, they're still sensitive, okay? But beyond that, as far as I know, we don't have good evidence suggesting that it will last for a long time. So don't, tell your friends and, you should start doing prenatal training. I'm just saying that they can hear, okay? But it probably doesn't hurt, okay? Because we actually, independent of this, we have evidence suggesting that prenatal music listening helps soothe mom, okay? So it actually helps mom. And so, so probably it doesn't hurt, okay? Okay, now, after you're born, so once you're trained on something, there's a signature in your brain. But interestingly, neonates are also sensitive to things that they are not trained on, okay? So let's look at this study. So this is a study by a group in Canada, and now she actually moved to France. So in this study, they asked 22 neonates to listen to sequences. So this is not just like speech sounds. So now they're putting syllables together, okay, sequences. So they asked these babies to listen to what's called a ABB sequence and also an ABC sequence. So like mu ba ba, that will be ABB. Mu ba ge will be ABC. Okay, so they have a bunch of these stimuli. Mu ba ba, mu ba ge. The question is whether or not neonates who are not exposed to language yet, at least not the full-blown language, maybe a little bit from mom talking, okay, whether or not babies are already sensitive to these sequences. These sequences are, the foundation, the building blocks of language, right? So, so they have babies wearing a hat like this. They use they use a method called near-infrared spectroscopy, or FNIR. Basically, they shine some light, okay, and then measure the oxygen level of the blood that might have absorbed the light. So when blood is oxygenated at different levels, that reflection of the light is different, slightly different. So that's what they're measuring. Because when you're listening to something, more oxygen should be rushing into a particular area of the brain. Okay, and so they use light to try to detect that. So that's called a near-infrared spectroscopy, or FNIRS. So babies would wear. So these are neonates. I mean, this is a picture as an example, but the subjects in this study, they're neonates. So neonates will be listening to mu ba ba mu ba ba mu ba ba mu ba ge mu ba ge mu ba ba mu ba ba, like that. Okay, and so they wanted to know if their brains, even the neonates, without having exposed to language, already know the differences. Okay, so this is a very complicated graph. What I want to tell you is that babies can actually already tell the differences between these two sequences. Okay, so especially in the left frontal lobe, so you can see differences between these lines. Okay, so you don't have to worry too much about what they are, except that there's a difference between how they responded to mu ba ba and mu ba ge. Okay, so ABB and ABC, kids can differentiate. Neonates can differentiate without having learned the language yet. Okay, so the importance of this study is that perhaps babies are already equipped with neural resources to help them learn and process language. So there's something that might be innate. I mean, I emphasize a lot of experience, but there's something that might be innate. So this could be an example of perhaps some innate ability that the child may have. Okay. Okay. So experience, innateness. So there are two things that are interacting. A very important element in child language learning is input. Okay. And for most babies, you get your input from your parents, okay? And so we're starting a series of studies trying to understand parent-child interaction at the Brain and Mind Institute. Some of you, if you have children, you might have been invited to some of our studies. And so we're trying to understand what kind of parent-child communication facilitates language learning. Okay, and how that parent-child interaction may be related to the behaviors that we observe between parent and child. And so we use FNIR again, and in this case, we will put the cap on mom and child, or sometimes dad and child. We also have studies looking at like strangers and child, and dad and child, like to try to understand they're in tune with each other. So basically, we're trying to understand brain attunement, whether or not their brains are in sync. Okay, and they will be doing a book reading task. Sometimes we ask mom to talk in what some may call motherese to the child versus adult-directed speech to see if there's a difference in how their brain may synchronize. Okay, we have 2 studies under review, and I'll tell you more about the results next time when you come to my talks, perhaps. But this is an example here. So this is when we have a parent and a child. And so one line is, so the blue line is a parent, the red line is a child. You can see that these two people's brain pretty much go together. It's not perfect. But then if you put a random parent with a child together, these two brains are not going together. Okay? So they're going together, and actually before they do a task, we can already see that their two brains are actually going together compared to strangers. Okay? And then when we ask them to go do a task, that's when they go together. Okay, so this is called parent-child attunement. We can, so this is our lab, and we are hoping that we can get a system where we can measure the brains of 10 people at the same time. Then we can like study both parents and child at the same time. Okay, that I'll know about that in about a month. Okay. Going back to neonates, now I put this in because parents always ask about bilingualism, and especially in this environment that we're in. So let's switch gear to talk a little bit about bilingualism. Parents ask this question a lot. if my child is learning 2 languages at the same time, would my child get confused? Right? So would that hurt my child? They would ask pediatricians, they would ask speech therapists, like they always ask this question, and I get this question a ton. And then I usually would use the study to explain to them that your child will not get confused. Okay, so let's look at babies again, neonates. Again, neonates. They don't have a whole lot of experience of language. They may be listening to some language in the womb, okay, but they don't have a whole lot of experience yet. So this is a behavioral experiment on neonates in which they use a method called high amplitude sucking procedure. Okay, so again, babies, we can't just ask, hey, Johnny, can you hear, right? We can't do that. So that's why we need to use more objective methods like brain methods. We can also use this method called a sucking technique. So babies suck, right? They just suck. Okay? They can express themselves by the rate that they suck. If they're interested in something, they suck faster. That's basically the technique. Okay? So it's not our study. So this is a study by Bias Highland. Now she is in Concordia University in Montreal. But she did this study, I think, when she was at UBC, University of British Columbia in Vancouver. Okay. So the nipple that they use has a special wire in it that would detect how hard and how fast the baby would suck. Okay, so that's how they do the measurement. So in this study, they had a group of bilingual neonates. Bilingual meanings they are from parents who are bilinguals. Okay, Chinese-English bilinguals, English-Tagalog bilinguals, and 15 monolingual English neonates. And in the first experiment, they would present some Tagalog sentences to the child, and then some English sentences to the child. And then they measure how fast the infant would suck. Okay? And here you can see that for the Tagalog bilinguals, Tagalog-English bilinguals, about half of the babies like English, another half like Tagalog. If you look at the Chinese-English bilinguals, again, about half liked English, about half liked Tagalog. And then if you look at the English monolinguals only liked English. Okay? Now, preference is one thing. Before you prefer something, you need to know what that thing is first. Right? So this is telling us that babies are actually differentiating these languages. These are neonates. They're not confused. Okay? They are differentiating to 2 languages already. And now they then, in the second experiment, they actually measure whether or not they can tell the 2 apart. Okay? And so, I mean, this is a complicated graph. The important thing is this here, is that if you're Tagalog English bilingual, you're better at differentiating these 2 languages than if you're English bilingual. The story really, the important message here is that neonates can differentiate. They're not confused, even they're little babies. Okay? So, and we have subsequent evidence suggesting that they're really not confused. Okay, ultimately, they are able to speak the 2 languages. Okay, now, some parents, their pediatrician may tell them this. Well, if your child learns 2 languages, your child's language development will be slower. Okay, so because in fact, some earlier evidence suggests that a bilingual child's language development may actually be slower. Now, but slow or fast depends on how you measure the child. Okay? So now we know that they're not slower because of studies like this. So in this particular study, they're measuring vocabulary development of bilingual children and monolingual children. Okay? These are English, Spanish bilingual children versus monolingual English learning children. Okay? When I said it depends on how you measure, well, if you measure just English, if you measure a child who's from a bilingual environment, just using an English test, the child is not as good as a monolingual English learning child. Because the bilingual child, for those of you who may have children growing up bilinguals, you know that for some words they only know in one language. For other words, they only know in another language. Okay? So that's why if you just measure one, they're going to miss like half. Okay? Now, if you measure 2 languages, so let's look at the data here. So if you only measure English in the bilingual group, it seems like they're kind of behind. Okay? Now, if you measure the Spanish as well, and if you add up their total language, they're actually way better than the monolinguals. Well, but if you add up the 2 scores, it may not be fair because the child may know apple and 苹果, right? So if you count it twice, that might not be fair. So then they can use a measure called total conceptual language. So if they know both apple and 苹果, that means that they know this fruit that's red. We only count it once. If they measure total conceptual language, that will be a fairer measure compared to the monolinguals. You can see that the bilingual children are actually better than the monolingual children. They know more words. They know more concepts. Okay? Now, these are between 8 and 30 months. Okay, in both comprehension for sure, and production, they are at least equal. Okay, so monolingual children's vocabulary development is at least equal to children who are monolingual. That's one study. I mean, there are a bunch of studies. This is a more recent study from 10 years ago. And so they looked at French or English monolinguals and French English bilinguals. If anything, the bilingual may be slightly better than the monolinguals in red. Okay, so eventually you'll see that, there's more and more data now suggesting that there actually, there's no disadvantage in terms of language development. Okay, I don't have time. Do I have time? Okay, so let me quickly talk about this. Okay, I'm not going to do the experiment. I was going to do the experiment. So there's evidence suggesting that if you're bilingual, there may be a cognitive advantage. Whether or not you want to call it advantage or not, it depends on how you look at it. But there are cognitive differences between monolinguals and monolingual children and bilingual children. Okay? And so in this particular study, they tested a bunch of kids, 104 kids, who are English monolinguals, Chinese bilinguals, French bilinguals, and Spanish bilinguals. And then they asked them to do this, what's called a switching task or flanker task. Okay? So the task goes like this. So I can ask you to name these colors. It's very easy to name these colors, right? So you just say red, blue, green, black, blue, green. No problem. Now, if I ask you to name the color like this, red, blue, green, black, blue, green. That's a little harder because the actual color and the word are actually conflicting. Okay? So this is also, now read the word. Okay, that's kind of conflicting. Okay, so you can ask children to do these tasks to see how much slower they become when they're encountering a conflicting condition. So that's testing your cognitive flexibility. The hypothesis is that when you have to speak 2 languages, you're constantly juggling, like doing like gymnastic in your head. Like sometimes you have to suppress that language. Sometimes you have to select that language. Okay, sometimes both languages are fine. So you're doing this gymnastic in your brain. So that may enhance your cognitive flexibility. And ultimately, what they found is this. So here, slower up is bad, okay, because you're slow. The monolinguals were slower than the 3 groups of bilinguals. Okay? So now, but this is only one study. There are now conflicting evidence suggesting that this effect may not be that robust. But at least we know that being bilingual probably doesn't hurt you. Okay, there may be some advantage as well in cognitive flexibility. There's a huge debate in the literature, and if you read the New York Times, there's like articles about, oh, these effects are not real effects and whatnot. But taken together, there seems like there's at least cognitive differences between the 2 groups, and these differences may actually be advantageous. Okay, I'm not going to talk about the cochlear implant stuff. So I was going to make a point about children with communication disorders. So there's a brain connection there as well. So let me tell you about this study. So far I talked a lot about the brain and language and music. I haven't talked about culture a lot, so let me talk about this study. Because we just published this as well. Okay, so many people would think that music is a universal language. Have you heard of this? Like music, like everyone experience, because why is it a universal language? Because the hypothesis is that everyone experiences music the same way. It doesn't matter which culture you're from, like there's something underlying music, this mysterious thing in music that makes everyone to have that same type of experience when they listen to music. Okay, at least that's kind of like a lay person's belief about music if you ask them to tell you about music. Okay, so we conducted this study to try to understand this universality of music. Is music really this universal language? Okay, so we conducted this study in 3 different places, 2 in the US, Arkansas, and Michigan. Okay, and then we also tested a bunch of Dong people in Guizhou. Okay, so this is completely distinct from these 2 groups. I think you would agree. Okay, but these 2 groups of people are kind of similar to each other. Okay, so they have shared cultural experiences. This group will be distinct from these 2 groups. Okay, so we conducted this study in which we asked these 3 groups of listeners to listen to traditional Chinese music and traditional Western music. And then we did this task that very few people have done. We just asked them to tell us stories about what they hear. Okay? So you can probably imagine how we tested our subjects in Arkansas and Michigan so they can come to the lab and then we do it. In Guizhou, we took a bunch of students, our master students in linguistics, actually. Every May for a couple of years, I would take a bunch of students to a Dong group that we have established a relationship. And so we'll just have like tables like this, and then like we have a translator because they don't speak Mandarin, okay, these subjects. We'll have a translator sitting next to them, and then we'll present musical stimuli to these subjects, and then they have to tell us stories about what they hear, okay? So this is like a kind of like a free response kind of task. Okay, and then we use computational methods to help us understand the relationship of words that they produce, okay? But let's look at here, these word maps first. So here, oops, okay. So when you look at a map like this, so cowboy is the most frequently reported word, okay, by our subjects. In this case, man is the most frequently reported word by our subjects, okay? So let's just look at these maps. So now C16 is a Chinese clip. W9 is a Western clip. So the actual clip is a lot longer, but for the sake of our talk here, I made it really short. So listen to this. So they listened to it for a long time, and then we asked us to tell us what you hear, right? So people in Arkansas would say a cowboy, old, sitting, a porch. Michigan people also said cowboy. I mean, remember, this is a free reporting task, okay? There was no fixed instructions. There were no buttons to press. People in Michigan also said old and cowboy, okay? So in this free response task. Now, let's go to demon, the Dong group. They said sorrowful, ancient, home, sad, man. Okay? So it seems like there's cultural similarity if you're from the same group, namely the Arkansas and the Michigan groups. But the demon people reported something completely different. Okay? We also did that with Western music. I mean, a bunch of clips. But again, this is just one example. Okay, I think you can agree that bird chirping is reasonable for this clip, right? Bird, animal. So both Arkansas and Michigan people reported birds and chirping, right? Look at the Dong people. They thought it was leaf, man, mountain, sound. I mean, they're surrounded by mountains, okay? So that's what they reported. And then we did some semantic analysis, so we can look at the relationships of words and then how subjects cluster together. And so you'll see these are all the demon people. Okay. Semantically, what they reported in terms of the meaning of the words that they reported is very distinct from the meaning of the words reported by people from Arkansas and Michigan. Okay. So we can quantitatively try to understand the relationship of these words. So what is this study telling us? Is music a universal language? So it seems like there's both a cultural component and a cultural specific component. Okay, so Arkansas and Michigan, they share the same culture. Their response to music and how they understand music shows more similarity than if you're from far away, demon in the Dom minority group. Okay, so music seems to be both specific and universal. They're both elements to it. So it's not like everyone is experiencing the same thing when they listen to music. Okay, so kind of quickly conclude, it seems like auditory input is fundamental to the development of spoken language and cognition in very young children, starting perhaps prenatally. Variation in statistical regularities that are characteristics of speech and music stimulate the auditory system in both universal and culturally specific manners. Different languages are governed by different sets of statistics and are nourishing to the brain. Even neonates do not get confused by different languages. Bilinguals are at least comparable to their monolingual peers in language development and may possess better cognitive abilities. May. Okay, so I was going to spend some time talking about, I mean, it's been an hour already, so I'm just going to quickly go through some strategies for enhancing language development, okay, just like in 2 minutes. Okay, so to me, as a researcher, a parent, and a speech therapist, the two most important elements of early spoken language learning are these. The first is the listening brain. Okay, so we need to born with hardware that can help us take in auditory information because spoken language is auditory, music is auditory. Okay, and for some reason, some children are born with better auditory system than others. And that can in turn help us predict whether or not they develop language well. But that doesn't mean that they're doomed because there's plasticity going on. And actually there are things that we can do to intervene. And I'll be talking about that. The second element to me that's important for early language development is quality parent-child interaction. Okay, it may be a caregiver, but usually a parent. We know that how parents communicate with their child is related to how well their child develops language. There's certain strategies that parents already do that will enhance the language development of their children. For some reason, some parents just do it. Some parents just don't do it. Okay. Now, importantly, parents can learn. Once they learn those strategies, once we intervene, their child's language development is actually better. Okay. So I'm not gonna. Okay. So music is one way, perhaps, to intervene. Okay, but I'm not going to talk about that. I do want to talk about this because this is sort of a commercial. So we are actually running various playgroup studies at the Brain and Mind of Institute, so please come join our studies. We have these activities like this is a music example. We teach parents online and in person and to use music to promote parent-child interaction. So please come join our study. So we're testing that, and that may change their how the child's brain responds after a course of intervention that we prescribe. Reading to your child is important. Now, let me talk a little bit about parents. So the role of parents. Parents are very, very important in the child's development in language because we need to born with the hardware to do it, but also input is important. And we know that language development requires high intensity and high quality language input. Okay? If you just go to a speech therapist, it's like an hour a week or 2 hours a week. That's not sufficient dose. That's not high quantity. Okay, if you're sick and if you need medicine, you need to make sure that you get enough medicine. You don't just take half of a pill. You need the entire pill. Okay, and so just going to a therapist alone is not going to make a huge difference because the dose is not enough. And children need to practice in their natural environment. Okay. And we have research suggesting that parent implementation of communicative strategies can actually enhance language development in their children. And so, for example, this is my collaborator, Megan Roberts at Northwestern University. She published what's called a meta-analysis at JAMA Pediatrics several years ago. She looked at 76 studies, including 59 randomized clinical trials. So clinical trials are studies that people use to evaluate medicine, like our COVID shots went through an RCT, right? So she reviewed a bunch of studies, including 59 RCTs, with over 5,000 children. And the conclusion is that if you adopt some strategies, your child's language can be better. Okay, and I'll talk about what those strategies are. And then these methods can be effective for children with and without language impairment. Okay? So these are the strategies. We call them prime early, okay? So what are prime early? So really simple, you just need to do it. So pause and listen. Don't just keep talking. Allow your child to talk, okay? Recast output. So when the child is saying a sentence that's not correct, you don't tell the child that no is wrong. You model a good example naturally. Okay, so if the child says, 一個車, so in Cantonese you can, 一個車, okay, so that's a common error, 一個車, you say, 係啊,一架車喎, okay, so you just rephrase very naturally, we call it recast. Intonation emphasis, so this is something that some parents do naturally. They will raise their pitch or emphasize certain important elements in words. Make comments. That means that when the child is doing something, you try to use language to describe what the child is doing so that the child can hear what you may be saying and make the connection with what they're doing with language. So, oh, what I do, this is what I'm doing in language. Like, okay. And then you expand and extend. So if the child says car, you say, yes, one blue car. Okay, so you add to the elements to expand that sentence so that the child can get more grammatical elements and learn more words. Okay, so it's easy to talk about them. It's very hard to implement them. Okay, and so in our lab, we are testing ways to teach parents how to do these things. We would have teaching sessions, and then we have coaching sessions. We make them videotape themselves, and then we go through their videotapes so that they would just learn how to do this naturally in their natural environment. Okay? Okay, so I'm not going to conclude because I'm running out of time, so I kind of concluded earlier already, but those are some of the strategies. These are my financial disclosures because some of the work that I presented related to my company. So I'm a founder of a spin-off company at Science Park. Foresight Language and Learning Solutions Limited is supported by Tissue and the ITF. And the EEG test is being sold under the trade name of Precision Listening. And we have 2 patent pendings related to the work that I just told you. So I have to disclose that because there's a conflict of interest. Thank you. So if you please go to our Facebook, like us, follow us, and we have many studies going on. We have community programs going on because sometimes we just say, oh, we have like a 2-session play groups, and please come join us. And then like, please come join us. Okay? That's it. Thank you. Question?
Thank you. Thank you very much, Professor Wong. Really very stimulating talk. Yes. So now, yeah, the floor is open for questions. And please, before you ask your question, state your name. Okay, I will start by stating my name because I didn't introduce myself at the beginning. My name is Klaus, and I am a lecturer for the General Education Foundation program. Okay. Yes. So
you can do it in Chinese.
Right. Yes. Yeah. Yes. Yes. If you, let us do like this, yeah, even if the talk is in English, but if you feel more comfortable, feel free to ask questions also in Chinese, yeah, and Professor Wong perhaps will translate, or if I understand, I will try to translate.
Okay.
Yes, please.
Yeah, thank you for the stimulating talk. So the basic position is that music and language, they may be related, and the music experience would enhance language learning, or language learning would enhance music learning. But I think, just by intuition, okay, a lot of musicians, actually, they are not good at language learning, or some very good linguists, they are not good musicians. So,
yeah, I'm not talking about those are necessary and sufficient.
About the relationship between the two.
Yeah, so they are not necessary in sufficient conditions. So it's not absolute, okay? But as a group, under the same conditions, all things being equal, that's what we mean.
Okay, so, you know, for treating the dyslexic children, so some approaches are using the music learning approach to do, but the results, I don't know whether the results are satisfactory.
That's my personal opinion, okay? So it needs to be very early if you want it to work. If they can't read already, listening to music a lot is not going to make them read. They need to learn how to read. Right?
Okay, just one more question. So is your research similar or different from those of Goswami?
So Goswami so we don't do research on dyslexia. Actually, Goswami, that's her focus, is dyslexia. Yeah.
But about the, you know, the core elements of language learning, about the pitch or the tone, whatever, are they highly similar or different?
In the greater scheme of things, I think they are similar, but in terms of the details, I don't think they're the same.
Okay.
Yeah, because I don't, so far we haven't done research on reading, really, and that's her focus.
Okay, thank you.
Yeah.
In the meantime, I will ask a question.
Okay.
On the, more or less on the same line of the relationship between music knowledge and music skills and language learning in a very broad sense. So, you showed us that in general, musicians tend, you noted, or either you or another group noticed that musicians tend to score higher in recognizing Mandarin words.
Yeah, okay. That's our study.
And so, if I remember correctly, the test was only for Mandarin, right?
Yeah.
Right, and so that greater recognition ability for musicians compared to non-musicians, does it hold true also for other languages, or it's mostly for tonal languages?
So our particular experiment has to do with neuroencoding. And so the technique that we use is really good for detecting how their brain encode pitch. So that's why we chose Mandarin as the language. Okay. Now, there are other evidence, not about the brain per se, suggesting that like musicians are better at foreign language learning. So that would be not necessarily about Mandarin. Yeah.
Thank you. Yeah, very clear. Thank you, very clear. In the meantime, I ask another question. So, from the audience, you can think, you can prepare, because it's really, extremely interesting and extremely useful. I'm also a parent of a young child, of a 4.5-year-old child. One question is, if I did I understand correctly that most of the research that you presented is for very young children, newborns and perhaps up to 2 years old? Or?
Yeah.
Right. Okay.
Actually, now we're starting a well, the autism study would be school-age kids. And now we're starting a study with school-age kids as well.
Right,
Yeah.
thank you.
Yeah.
And so there was, in a slide that you showed us about checking so-called, let's say, prenatal training.
Yeah.
Okay, a kind of training, okay, kind of prenatal training. But there was a result that to me appeared a bit puzzling. I don't know whether we can see it again, because for vowel recognition, for pitch, again for there was the pitch and vowel recognition, I think.
Yeah, this one.
Right, for vowel identity, right?
Yeah.
So the part for vowel identity.
It didn't work.
If you can explain, because I don't understand.
There's no statistical difference between the two groups for vowels. Perhaps because it's of a higher frequency than voice pitch.
Yeah, what I mean is that why? I mean, you mean that the fact that those with the training, the black one is the black.
The black is the
black
trained
bar
group.
represents the trained.
Yeah.
Trained children. Okay.
Yeah.
And so in the case of vowel identity, it seems they score much lower than.
Yeah, there is no statistical difference between these two. So they're
Okay,
like,
statistically, it's
yeah.
not the difference.
Yeah.
Is okay.
Yeah.
It's not significant. Okay, I understand. Yeah, okay, at least the error.
yeah.
Yeah. Because at first, I mean,
Yeah, it's counterintuitive.
The two appears
Yeah,
quite
right.
different, but
Yeah.
the difference is not significant. Okay, thank you. Thank you. Yes, yes please. Just a moment. The microphone.
我想問下我知道即係父母對住 BB 講嘢係好緊要啦呢樣嘢。咁假若譬如有個 language 我都未必係咁叻嘅，咁我如果播個 recording 俾佢又有冇用咧？
Okay, so the question is whether or not an infant can passively learn a second language if the parent can't really speak that language, right? Am I paraphrasing correctly?
係，或者譬如英文咁，可能我想佢有 British accent 咁。
Okay. I actually have a YouTube video about that, so if you can go online and you can watch it. So there's a study by a group in Washington in which they asked children, English learning children in an English environment, not knowing Mandarin, to try to learn Mandarin using a television. In another condition, they had an actual Mandarin teacher, Mandarin talker, interacting with the child. What they found with babies is that television interaction, that television lack of interaction didn't really work. It really needed that in-person interaction to make it work. Okay, now these are infants, okay? That's not to say if you look at older children learning vocabulary, okay, and watching certain kind of high quality TV won't help you, okay? Because I saw it in my own children. Actually, they learn a ton from watching, okay? But at least at the very beginning, from the studies from that group that I just talked about, that real life interaction is very important because language requires practice and use, not just passively listening to it, okay? So in the case of my kids, actually they get to interact with people who speak that language, okay? Yeah. So don't just rely on TV or watching TV or the Disney, whatever, 迪士尼咩美語世界, okay? So they actually have, there's no evidence suggesting that actually works. Okay, that interaction is important. Having said that, it's important to also, if you go on to my YouTube thing. So I want to highlight that watching TV, so some parents are really worried about their child watching TV. Okay, so from the language development standpoint, what we worry when you have your child watch TV a lot is that that takes away time from interacting with you. And the evidence saying that when a child watches a lot of TV and the child is not developing well is not necessarily because of TV, it's because they don't have the time, because you as the parent just want to do the easy thing to let the child watch TV all the time so that you can do something else. That takes away the important parent-child interaction that I talked about. Okay, so when a child is young, the recommendation by the American Pediatric Association is that if you want to watch your child to watch TV, you need to watch TV with the child. Okay, you don't drop the child in front of the TV and then you do something else. Yeah, okay. Yeah.
咁如果音樂咧，音樂需唔需要係
The Mozart effect thing, there's actually no evidence, but it doesn't hurt.
即係會唔會話係我 in person 要彈俾佢聽嘅？即係我即係 exaggerate 咁樣講。
So in our play groups, we have music play group going on in the laboratory that we're testing. The important thing about our play group, the definition of a play group is that there is parent participation. We're using music to enhance parent-child interaction. Okay, so again, it's not just passive listening. That's the thing that we want to avoid, is that there's this passive thing going on. We actually teach you how to interact with your child. We have these prescribed games that you do. Yeah, so it's the interactive component that we hope to enhance that synchrony between you and the child. And so that you are more what we call parent-child attunement. You're more attuned to your child's needs. And then in language communication as well. You know what to respond when the child says something because you understand what the child is saying. And then you build on what the child says. That's what we want you to do, expansion. Yeah. I mean, have the child, learn piano, that's good. Okay, I'm not saying that that's not good. When we're dealing with infant toddlers, we want you to be interacting with your child. Yeah, and back and forth. Yeah, we want, so if they're watching the hand, show, show the 先生頭，先生，so you do it together with the child. Yeah. Okay.
嗱，用語言嚟講咧，即係細路仔咧就由細俾我哋摸 up 大咗，即係喺一種嘅語言或者一種嘅講嘢方，即係聽嘢嗰個通點樣樣。咁會唔會有一種方法係我哋使到？即係我哋訓練嘅細路仔，好早訓練嘅細路仔能夠好適應將來個世界有唔同嘅語調或者語言，你容易去容易啲即係 perceive 到又講得到，即係咁就變咗佢會係比較係開放性啲或者彈性啲去接受到唔同嘅聲音啊或者係語言。嗱，好似我嚟講咧，我係潮州人，咁我講廣東話。咁我去到，咁我唔講英文㗎，肯定係嘛？咁我去到大陸咧，我去到潮州咧、汕頭咧，我又唔識講潮州話喎，但我識聽，因為我自細聽咗啊嘛。咁聽但我識講。咁英文我哋好少講嘅，係去到中學以後你做嘢有機會講，或者讀書嗰時你要講。咁你先識，但係覺得就好似難啲。但係我聽得多英文咧，我又識喎。咁然後啦，到而家啦。再去大陸啦，我有一次試過唔識講嘢嘅，因為去大陸唔知講潮州話定講普通話，兩個都唔好熟，識聽唔識講。咁如果我哋自細嗰個即係接收嗰個語言咧，或者嗰個聲調咧，即係比較係開放性啲咧，咁我去到咧，我容易吸收到啊。咁我就嗰個問題就係喺基本去成長嗰個階段裏邊咧。有冇啲更加比較開放或者靈活啲嘅方式咧，訓練我哋細路仔咧去接受將來唔同嘅語言或者聲音？
嗱，我用中文答咗先，跟住我揾英文答啦。我唔知我係咪完全咁樣理解你嘅問題，但係我可以答其中一樣嘢。我哋知道嘅咧就係雙語嘅小朋友咧，當佢學第3種、第4種語言嗰陣時候咧，佢係會叻啲嘅，係會容易啲嘅。即係我哋有啲咁嘅數據嘅。咁如果你想佢彈性啲咧？其實你咪佢學多種語言啦，咁佢就會有機會將來彈性啲咯。即係呢個係其中一個 solution 啦。In fact 咧，其實有啲 evidence 就係話嗰個，因為語言咧有個窗口嘅，有個時間性嘅窗口嘅。咁咧喺頭嗰6個月嗰陣時候咧，小朋友咧可以聽到好多唔同世界嘅語言嘅聲音都聽到，但係喺6個月左右咧就會閂咗個門咧，淨係聽到自己嘅語言嘅啫，即係自己嗰個環境嗰個母語嗰個語言啦。咁但係一啲雙語嘅小朋友咧，嗰個窗口咧可能會長少少喎。OK， 咁我諗就係俾佢一種多種唔同嘅 input， 多種唔同嘅嘅 experience 啦，嗰個咁嘅經驗啦，咁咧就可能會幫助佢第時咧就會彈性啲。嗱，我講嘅嘢未必有證據嘅，但係我哋有嘅證據咧就係咧識2種嘅人咧學3種係會快啲嘅。OK， So the question had to do with how to make your child more flexible when the child is older. And I'm simplifying. And so my answer to that is that from the scientific standpoint, we know that children who are bilingual can learn a third or fourth language easier than if you are monolingual. So that could be an answer to that question. 猛咁樣無限延長。嗱，雙語啦，就係雙語就係可能係其中一個辦法咯。OK， 係啊。即係嗱個窗可唔可以重開咁樣喎？咁嗱你啲細路仔可能你2歲叫佢再學一段新語言佢 OK 嘅喎，係咪？咁但係即係以我哋見到嘅數據就係一啲雙語嘅細路仔可能8個月、9個月或者甚至1歲咧，佢都未 commit 佢自己個語言嘅，嗰個窗可以長少少嘅，唔係6個月嘅。呢個係一個 hypothesis 同埋有少少嘅證據啦嚇，有一個假設。哇！好驚喎 ！Professor Thomas Lee, he is the actual language acquisition expert.
Thanks, Professor Wong. Very exciting talk. Just two questions related to your recent finding. So neuroencoding of pitch will predict vocabulary growth. Just trying to interpret this because you seem to have a model that is predictive. Just trying to understand the implications of this and like to hear what you think of this. Well, vocabulary involves not just sound, but also meaning, right? But neuroencoding of pitch, I guess it's purely at the acoustic level. So the first question is, presumably the sound is extremely important, even in the absence of the meaning at the early stage. So how do you interpret this? That's one. The other question is from some of the early studies, right? Maybe they might be outdated. We know that the processing of speech and non-speech, there's a big difference. Processing of sound as speech and processing of sound as non-speech. So the question is, when you have infant perception of early pitch, the kid doesn't really know whether it's speech or non-speech. So I guess your results might change the way we think about this speech non-speech distinction, or I know how you look at the relationship between such findings and the speech non-speech distinction. Yeah. So the first question is how does meaning come in, right? In terms of the
yeah, I mean that's a good question because we're only studying really young babies and making early prediction, and my hunch is that because there's like a kind of like a hierarchy of what you're learning, so you have to be able to differentiate sounds, and then you learn words, and then like if you have a good vocabulary, it's easier for you to build language that's a little bigger. So the advantage that you have if you have a good speech auditory encoding is that you may be able to acquire more words, which makes the later processes easier for you. Okay, we know from like Mark Bornstein's work, for example, there's huge amount of developmental stability. So 6 months of child language can predict 1 year, can predict 18 months, can predict up to 15 years, right? So it's probably, I'm guessing, is because when you have a good foundation and then when you keep adding and adding and adding, it's just easier for you. So we're not trying to make the claim that speech encoding would predict like really complicated syntax. But because you make it easier for them to learn words and therefore phrases and whatnot, it's just making the process easier. Okay, I think that's how I see it.
Yeah, it makes sense. So if your mastery of the sound image is easier, then maybe it facilitates the association between sound and meaning. Maybe that's what it's telling us.
Yeah, but we're doing actually some other experiments trying to understand this a little better. But at least that's what we're seeing now. Okay. And also, there's actually a lot of stability in the neuroencoding signal as well. So if you are good at time point 1, you're good at time point 2, you're good at time point 3. There's just a lot of, for whatever reason, what you're born with is just kind of stable over time. And we need to do a lot to intervene to make a difference, to change it. Okay. Your second question about speech and non-speech. We are only testing speech stimuli. I don't know what's going to happen if we use a completely, we just ask the child to process pitch in the absence of a syllable. I don't know what's going to happen. Now, what we did, though, was that in our paradigm, we had native and non-native tones. So these Cantonese kids, they listen to both. Some of them are Mandarin tones that they heard, and some are Cantonese tones that they heard. There's actually no differentiation of the two for early processing. So we think that this is probably tapping into some really general mechanism rather than language-specific mechanism. Yeah, but we're waiting for the longitudinal data to come back. For later prediction, maybe it really needs to be Cantonese that will predict a later language.
I guess the question is, how would the kid know that it's speech? It's just acoustic stimuli to the kid, right? So
yeah, but it's a voice that they're used to. Like they're used to not just, the stimuli is not from their mother's or their parents' voice, but they have experience. They're keeping track of the acoustic statistics of what speech is like. Actually, there are experiments showing differentiation of speech and non-speech. So it's not that they don't know. They know French from non-French. They know French from English, from the rhythm of it. Yeah. So they're keeping track of that statistics, I think. Regularities. Yeah.
Thank you.
Yeah.
Thank you very much for your talk. I was interested in about music and culture. In one of your slides, you just talked about does people from different cultures preserve music in the same way? And you did some very interesting experiments and show that music experience is both universal and cultural specific. And your example obviously show that music is cultural specific because different cultures associate different meanings. But how about the universal aspect? In most aspects, is music experience is universal.
I think they generate, like here, there's some relationships of what one person is saying to another. So that's what we mean by universal. So when you look at the Arkansas group and then when you look at the Michigan group, they're kind of generating the same thing, even though those are two different individuals. That's what I mean. It's like it's universal to these two people. Yeah. So it's a hierarchy of similarity. Yeah.
Thank you, Professor Wong, for your wonderful talk. I would like to ask about the brain wave that you showed earlier on. Because there's also amplitude and frequency somehow matches the pitches. I want to know, what does that amplitude and frequency measuring? Is it the flow of electrons in the neurons?
Both. Actually, there are frequency domain measures and also temporal domain measures. So there are like about 60 some measures that we use in our predictive model. Yeah. And there are measures that are more related to dendritic processes. There are measures that are more related to myelination processes as well. Yeah. So we put all of them together. And actually, as we speak, we're probably doing simulations in our computers. And so far, it seems like every bit contributes to it. Yeah, it's not like just one measure. So both. Yeah.
I mean, what does that curve representing? Is it the activity of the neurons or?
Which curve?
I mean, the earlier ones. I think the first few pages. Somehow you put on the higher pitch da and then lower pitch da, and then somehow you show the other.
So this is a waveform?
Yeah.
So from this waveform, we can do all sorts of analysis from this waveform. Yeah, so this is not one thing or another. So from here, we can do Fourier analysis to For example, to extract the frequency patterns, we can measure timing, latency. So this is, this is the raw files that we get, but then we can do all sorts of analysis.
I guess, Professor
and then
Wong,
we compare this with this. Yeah.
I guess also, these are questions also whether that is the input, right? Low pitch, high pitch.
This side is input.
That's the input. Then
this is the measure, the obtained.
Yeah, Sorry, those signals are electrical activity in certain areas of the brain, right?
Yes.
That then can be, I get you correct me if I understand wrongly. That then actually they practically they have practically the same frequency as the input.
Similar, yeah.
And so I guess that then what you do, the sound that you played, you showed us that the sound is almost the same. The sound is the new translation from the brain to, the signal translated again into a sound.
Then we can play this back.
That is the electrical signal in some parts of the brain.
Yeah, this is the...
And then we can play back in sense artificially. Okay, I guess that is the question, right? Yeah.
Oh, sorry, yeah. Okay,
so we play...
I gave you a much more complicated answer.
That signal, we play back...
Yeah, we play this back to you.
Because
if it's a waveform, we can just play it back.
Yeah.
Yeah.
My question was on the right column, those waves.
Yeah.
What does the amplitude and frequency of this? Is it the inflow of electrons or?
Oh, so these are the neurons firing. It's most phase locking, what we call phase locking of a bunch of neurons, mostly from the inferior colliculus, like one part of the brain, but not all of it, because we also measure some cortical responses. It's just like so from the ear to the brain, there are multiple relay centers, multiple parts of the nervous system. So this is mostly measuring from one, but there are also contribution from other centers as well. Yeah.
It's quite amazing that the neuron's activity frequency also responds to.
Yeah, it is. Yeah, I think so. Yeah, it's intriguing. Yeah. And we didn't invent this, by the way. So this is a method that has been used for decades. Okay. Yeah. So like there are animal models, and like they stick an electrode inside, and then so that's why we now know a lot more about this signal. Yeah.
There's a question.
Excuse me. Yeah. I have a question regarding to the interim conclusion.
Yeah.
Can you put the PowerPoint? Yeah. Okay. So for the first conclusion, so it states that auditory input is fundamental to the development of spoken language and cognition in very young children. So, so if this statement or proposition as a research conclusion, so it seems to me just stating the obvious. Mm-hmm. So that is, you say something which you don't need to do any research. It's already true. The reason is auditory system is important for you to learn a sound. Because if a child, you never give him to experience a sound. So he will never develop the auditory systems. So because the two auditory input, unless you put the auditory input as a specific, what kind of auditory input, then this specific kind of input, X, will have impact on Y. So then this is a research. And also the word fundamental as in the research. So what's the meaning of fundamental? The degree. Can you say this degree, reaching a certain degree, then it is fundamental. If not reaching a certain degree, it's not fundamental. So in order to let the reader of the research to use the research and understand the significance of the research, then you must have a very clear definition of what you mean by fundamental because fundamental is not a quantitative statement, not a quantitative word, but a qualitative word. So for qualitative word in a research, it had a certain discount on your research already. So this is my feeling. So because after reading this statement, I can't get the significance of it.
Okay, thank you. I think this is a very fair critique. But here, so what I'm trying to achieve here is to give a really broad overview of not only my research, but also other people's research. And so this is really just a broad statement for public kind of context, rather than building a computational model to try to quantify how much do you really need. So that's really not my intention there. But I agree with you, and I think your critique is well taken. Yeah.
咁我有一個問題，我唔知係咪一個 stupid question 啦，但係我照問咗先。咁就係我想問下，其實我哋點樣可以去 distinguish 到一個 infant 係有能力去分辨到邊啲嘢係 random sounds， 邊啲嘢係一啲嘅真係有 meaning 嘅 sound 咧？
邊啲係一啲 random 嘅 sound， 邊啲係一啲有 meaning 嘅 sound？ 嗱so 我哋可以做一啲 experiments 咧，就可以叫個嘅 infants 咧係去 pair 嗰個 sound with 一個 object 嘅，一個 consistent 嘅 object 嘅。咁呢個我哋叫 word association task 啦。咁有啲嘢可能佢學唔到嘅，有啲嘢學到嘅。OK， 咁 that's one way to do it。咁我哋知道呢個 association task 咧，要啲大個少少嘅 BB 咧至會做到嘅，一啲你4個月嗰啲咧就未必要做到嘅。OK， 因為可能有啲 cognitive 嘅嘢 going on 啦，佢至會學到嘅。So I don't know if that answered your question.
唔該，教授。
Can you summarize?
Oh, sorry.
Again, no, so, thank you very much. Can you just summarize in English?
If I understand the question correctly, so he was asking, how can we tell whether or not the infant perceives a sound as random or something that's associated with meaning? And my answer to that is that we can actually give what's called a word association task to the child. We can pair that with an object, so the object becomes an object of meaning. And usually we do this task later, in later infancy or early toddlerhood. If it's too young, the child cannot do it. Yeah. So there are certain patterns the child just fails to learn. Okay? Until they're older, usually.
I have a potentially related question, only potentially, to this question and also the questions of Professor Lee earlier. So, about the results with the bilingual Tagalog English children and Chinese English. So, it seemed, you said that more or less also for Tagalog English children, the results are more or less 50-50. Okay, I mean, in the sense that they equally like English and Tagalog, but again, visually, it seems that
they prefer Tagalog like one a lot more.
Tagalog,
right. Yeah, I know what you're talking about.
The children of Tagalog people.
I think the point here, is their study is
but
bias.
I'm asking this in a very positive. I mean, not as a criticism. On the contrary, in this case, I want to ask: is there something? So, is it possible that perhaps Tagalog's parents, particularly Tagalog's mothers, the way they speak to the children is perhaps remarkably different from other parents, or
I mean, perhaps like like the pitch is different, for example. Yeah, I don't know.
Because the results seem quite different. Yeah.
So what they wanted is their study is their study. What they wanted to highlight is that if you're bilingual, there's a split between the two. Yeah. So, but whether or not there's some reason why they want the Tagalog more, I mean, I think
so that part has not been investigated. So, what I mean, that question has not been investigated.
Right, as far as I know,
But right, yes. Thank you. So I think, yeah.
Okay, great.
Okay, let's say if there is one last question. Otherwise, if there are no further questions, we can thank Professor Wong. Okay, thank you very much, Professor Wong. It's been really nice. Thank you very much. Thank you.